Okay, guys. So this first video you're going to watch is over nuclear chemistry. Nuclear chemistry has to do with radioactive particles. What do I mean by the word radioactive? The word radioactive refers to particles that break down naturally on their own or produce radiation. So this has to do with atomic bombs, x-rays, cancer treatments, any type of nuclear chemistry. You're going to see the words fission and fusion that have to do with nuclear reactions. Nuclear reactions only happen with things that are called nuclear particles, or typically isotopes. Now, if you remember, the term isotope refers to an atom of the same element whose neutrons are different. So this would be considered an isotope of uranium. I know that it's uranium because the atomic number is the atomic number on the periodic table for uranium. However, the number on the top is the mass number of this specific isotope. So in nuclear reactions or nuclear chemistry, you're dealing with isotopes. Okay, isotopes don't seem to be very stable in our environment and can eventually break down on their own. They don't need a reaction for it to happen. They will do it naturally. Okay, so you're going to be seeing lots of isotopes. Remember, and that's kind of a review for you. This is the mass number, which is protons plus neutrons. And this is simply the protons from the periodic table. Okay, so let's look back at some actual radioactive particles. They look like isotopes, but they are actually types of radiation that get emitted during nuclear reactions. The first type is called alpha, and he looks like what we call a helium particle. This basically means that during alpha radiation, 4 protons get emitted, 2 protons get emitted. Okay? That means they get released or they get absorbed during a nuclear equation. This is what an alpha particle looks like. You have to be able to recognize him by sight. This is what a beta particle looks like. A beta particle is when you have an electron that gets kicked off in a way that he's negative, right? He stays negative. He gets kicked off during radioactive release. During a nuclear reaction, he gets released, and he's called a beta particle. This is called a gamma particle. Now, gamma radiation or gamma rays come from medicinal chemistry. This is the type of radiation that you're getting in x-rays and MRIs, CT scans. The type of radiation that gets entered into your body to try to kill out cancer cells. But he looks like this. He comes in the form of a wave. He doesn't really have a particle. That's why he's kind of the most dangerous. He has nothing that has to actually permeate a substance. Here at least you've got a proton or a neutron or an electron. They have substance. They have mass. This really has no mass. It's just radioactive waves, all right, which can travel right through our bodies. So that's why he is considered the most dangerous, the most penetrable, meaning he can penetrate anything except for lead. This guy can go through anything but skin. He's not very dangerous, obviously. We can't have alpha radiation in our bodies. We're covered by skin. Beta radiation can be stopped by clothes or paper. So as long as we're covered with clothes or a paper suit, we're protected from beta radiation. So what you have to be able to do is first recognize these 3 types of particles, and then you have to be able to balance a nuclear reaction. Now this is just like balancing equations that you're doing now, just a little bit easier. There are no coefficients, there are no subscripts, they're simply numbers on the top and the bottom. Well, here's your arrow. And I want you to treat your arrow like it's an equal sign. Okay? So if you have 2 things on one side of the arrow that must add up, that means when you add their numbers up on the top and the bottom, they have to equal these numbers. So this is how I work this out in my mind. What 2 numbers, when I add them up right here, what number plus 4 will equal 209? And that's 205. So 205 plus 4 equals 209. On the bottom, what number plus 2 will equal 83. Well, that would be 81. And from that, you can pick which element you're dealing with. You look on the periodic table, you find number 81. I know lead is 82. This is the element right next to 81, but I don't have my periodic table. Super handy. I do not know what element number 81 is, but you guys can look that up and fill that in. The element symbol for 81 on the periodic table goes right there. Okay? You also have to be able to look at this reaction and determine what kind of reaction it is, what kind of nuclear radiation is getting emitted during this nuclear reaction. And you're just looking for one of these. You're looking for an alpha particle, a beta particle, or a gamma ray. And obviously, we see an alpha particle in the equation. So this is called alpha decay, right? So let's do a little bit more practice on balancing those equations. All right, have another one at the top for you. Simple numbers. You're trying to get these numbers on the right side to equal these numbers on the left. And here's where you're adding. You see this plus sign, which means you have to add them up to get them to equal this. So 26 plus something will equal 28. That's 2. 26 plus 2 equals 28. 12 plus some number equals 13. 12 plus 1. So 12 plus 1 equals 13. Then I simply look on the periodic table. I find the element that matches this proton number. Remember, in an isotope, the number on the bottom is the atomic number, or the number of protons. So which element has one proton? Hydrogen. Okay? In some nuclear equations, you won't typically see alpha decay. Okay? You won't see that typical particle, or a beta particle, or a gamma ray, and that's totally fine. Right? For all intents and purposes, this is just practicing being able to match up those numbers and get the numbers right. Okay? So this is how a question will read. I just want to point this out. This doesn't go with this, or it can go with this. Which of the following, this is multiple choice, by the way. Remember, end of course is multiple choice. Which of the following particles balances the above equation? They'll give you an equation, above or below, and then you'll have 4 choices. Okay, so you can do this 2 ways. You can sit here and figure it out on your own and see if your answer's there, or you can take each answer and plug it in to your equation and see if the numbers match up. Okay, so I'm just going to work it out by simple math. Notice this time I have plus signs on both sides of the arrow, which means my numbers have to add up here and here to equal the totals here and here. So since this side is complete, I'm going to add up my totals on the right. 226 plus 1 is 227. 88 plus 1 is 89. So these are my total numbers on the right side. So I need for this number and this number to add up to be 227. So 223 plus 4 equals 227. 87 plus 2 equals 89. And now my equation is balanced. Mathematically, it's balanced. I have the same number of protons and neutrons on the top and have the same number of protons on the bottom. Okay? And then now I have to pick my element. Number 2 on the periodic table is helium, which obviously tells me that this is an alpha particle. Okay? So just a quick review on balancing nuclear equations and the types of particles. You have notes and practice over that. If you have any questions, you can email me, or we'll spend maybe 5-10 minutes going over that in class just to review. But this should totally help you. If you have any questions, just email me. All right?